we are going to examine how we can take the exact same problem, and we could use either a linear model or an exponential model in order to predict the value of a car later in time. So let's go ahead and let's write this. This is our initial, so please write initial above this. I just spelled initial wrong. There we go. So we have an initial amount, and then we have a period of time later on with another amount of the value of the car. So I'm going to say I have one ordered pair. This is initial, so I'm going to say 0. So my t equals 0 is the year 2002. So 0 is my time, and my output is the value of the car. Time is my x. I'm starting the year 2002. That is t equals 0. My next ordered pair is 2007. That's 5 years after 2002, so 5 goes with 1200. Now, a linear model is y equals mx plus b. I'm going to start by identifying what is that slope. So m equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Do I want to see your work? Yes, I do. I'm going to call this my x1, y1 if you're forgetting how to do this. And so I'm going to do 12,000 subtract 20,000 and 5 subtract 0. This is my slope. So I end up with negative 8,000 over 5. Now, I'm going to take a calculator really quickly and see what does that equate to. And that divides into being negative 1,600. And we want to think about that. That makes sense because the value of the car over time is decreasing. So this means per year, I can anticipate that the value of the car will go down 1,600. I'm going to come back up here. Y equals negative 1,600 x plus b. Now I'm going to take a second ordered pair, 512, and I could plug that in order to solve for the b. Or if you remember back to 8th and 9th grade, b means what is the initial amount. So what is the initial value when we start this? 20,000. Y equals negative 1,600 x plus 20,000. There's our equation. Now we're going to use this in order to calculate the value in 2010. So I'm not going to plug in 2010. What t value is associated to 2010? And how did you achieve 8? You are correct. Okay, so I'm going to write, so my final amount is negative 6,000 times 8 plus 20,000. And I get an answer of 7,200. That's what I believe the value would be. Now let's take that same data and let's now use an exponential model. So this is a little bit more confusing about how we're going to do this. So we're going to take what we know. We know the P is the initial amount. So we're going to take 20,000. And then we have one other point that I haven't used. I've used the initial, so I'm going to use this other value. So the end amount is 12,000, and I have e raised to, and I want to know what the rate is, but I know the time that corresponds to 12,000 is how many years? What does 12,000 correspond to in terms of the number of years since we began this? 5. If I'm trying to solve for r right now, I'm going to start by dividing by 20,000. So I'm taking 12, dividing it by, if we can turn it into a nice terminating decimal, we can, 0.6 equals e raised to the RT. Now my goal is to solve for r, so I need to eliminate that e. And so to do that, I'm going to do log base e on both sides, which is the same as ln. So the ln of 0.6 equals the ln of e raised to the RT. And my t, by the way, I need to leave it as 5. I meant to leave this as 5 previously. Okay, on the right-hand side, these are going to simplify to 1. My r times 5 goes in front. So whether I write 5r or r5 is the same thing. And my last step will be to divide by 5. So on your calculator, take ln of 0.6, enter. Get an answer, divide by 5, enter. Okay, so what is our rate here? It's ugly. Now we're going to write down this equation. So this is my equation. I have A equals 20,000 E, and now I have this really ugly decimal, negative 0.10214. 1651248 times t. This is my equation. With your partner, please use that equation, and I want you to answer part D. You have 30 seconds to begin. Part E of this problem. I know what my final amount is. So this amount right here is going to be 10,000 and I need to solve. Now I'm going to be lazy right now. You ready? I'm going to be lazy. Let's come up here. I'm going to clear everything. Second plus 7, 1, 2. Go up to this. I have my equation. 20,000. And I'm going to take it times E raised to the negative point. Let's slow this down so I don't make any mistakes. I do need to adjust the window. Remember, your X talks about time. So it's like, think of it as referring to the T's. I'm going to go between 0 and maybe 12 to go up far enough. And my Y's talks about value. At most, this is going to be 20,000. And we know that it's decreasing. It's decreasing from that point. Okay, so I'm going to do a zoom fit to see what this looks like. This is my graph. And I'm told when will the year be in which the value of the car will be 10,000. So I want to know, where do these intersect? And I can see here's my answer, approximately 6.78. So in the year 6, but what does that mean? We can't say in the year 6. So what was the initial? So I can write down 6.78, but what's the initial year for this problem? What is t equals 0 equal to? What year? 2002. So I'm going to add that onto that so we can say in the year 2008. So it's not the beginning, but in the year 2008, we can see that the value of the car will now reach 10,000.